All right, hi everybody. It's nice to see some familiar faces in the room. But for those of you who I don't know, my name is Sarah Hodges. I'm an industry marketing manager here at Autodesk, and I have the pleasure of being joined today by Armando Darling. He's our technical marketing manager, and also by Kelly Cohn. He's innovations director at the Vet Group. And what we're going to do today is we're going to start by talking to you a little bit about the breadth and depth of our portfolio, talk a little bit about some project examples from our customers, how they've used the portfolio to really imagine, design, and create a better world. We're then going to move through taking a look at a product demonstration. Armando's going to show you some of the latest and greatest products and features for 2013. And then I'm going to be joined by Kelly, and Kelly's going to take you through some real-world examples from the Vet Group that use the full Autodesk portfolio. So before we start, I wanted to say a couple of things. I'm going to talk about things in really a category of three things. It starts with extending BIM, so you're going to see how we're really expanding our tool set, extending BIM through design all the way through to construction. You're also going to hear me talk a little bit about how we're expanding to the cloud. You probably heard Amar talk this morning about Autodesk strategic investments and moving things to the cloud. The third thing I'm going to talk about is how we're providing greater flexibility and accessibility with expanded tool sets, automated workflows, and the ability to move some of our products into the cloud, providing people with broader access from anywhere at any time. So before we get into the presentation, I wanted to also talk a little bit about this time of the year. Believe it or not, we're almost on the 10-year anniversary of when we acquired Revit. 10 years ago, Revit was predominantly designed for architects. It was a tool that entered into the industry to really replace CAD-based workflows. And as you see here on the screen, it's a snippet from one of the marketing videos that was developed from Revit at the time. It was really focused on architectural design, providing tools that supported design needs and documentation needs of architects. And if there's one thing that I want you to keep in mind when you leave the room today, it's how far we've come. In 10 years, we've evolved from a tool that supports architectural design to introducing Autodesk Revit, that we're going to spend some time talking today about, that has the tools in there to support architects, MEP engineers, structural engineers, and contractors. You're also going to see the expansive breadth and depth of our portfolio that's really taking us beyond just architectural design, enabling us to support design, visualization, simulation, documentation, and construction. So let's keep in mind 10 years ago where we were throughout the presentation today. So I want to kick it off by talking about what we see going on in the AEC industry, or what I should say, the customers that we work with see going on in the industry. There's four things I'm going to highlight. The first one is BIM adoption. Many of you are familiar faces to me, and in fact, you were in the room with us 4 years ago in Waltham when we were talking about a very different marketplace. In fact, we were talking back then about building information modeling. The question was, what is BIM? We'd seen architects move to building information modeling. Engineers were still a little bit skeptical, and they were continuing to ask us, I hear about BIM, I don't know what it is, help me understand what BIM is. I'm pleased to say that standing here today, that is no longer the question. The question is, how do I do BIM? The market has changed so extensively. We've seen BIM adoption from architects, MEP engineers, structural engineers, contractors, even owners, that the question has changed. In fact, in 2009, McGraw-Hill published some research. That research told us that today, by 2012, we would see adoption of BIM among MEP engineers triple. We would see adoption of BIM among structural engineers double. I can tell you from the firms that we speak with and some of the customer examples that we're going to show you today, it's absolutely true. The other thing that's different today than 4 years ago is contractors. Some of you may have participated in the construction session just down the way. Contractors are seeing tremendous value in intelligent models for documentation, for installation, and for construction. We've also seen owners come to the table concerned about cost predictability, energy efficiency. Armando is going to walk you through the new tools in our portfolio today using a hospital design project. So let's talk about hospitals for just a minute here. I'm confident that for most of you in the room, the hospital that you were born in probably still exists. Hospitals have a tremendous lifespan. Why I bring this up is because the total cost of a hospital project actually comes post-production. 80% of the cost of that building happens post-construction. So you can imagine how concerned owners are about cost predictability before construction to really influence those life cycle costs. This is a very different conversation than we had with you 4 years ago. The other thing that's happening is that there's global BIM mandates. So for example, by 2016, if you're doing work in the UK, you're going to be required, if you're working on either a new building project or new infrastructure, to use building information modeling. By just next year, anybody doing work as an architect in Singapore, that a project is over 20,000 square meters, is going to be asked to do BIM. We see similar things happening in China and Korea. This is truly a global trend that's happening. So the second thing I want to talk about is efficiency. I've mentioned a lot about the industry being different than it was 3 or 4 years ago. The other thing that's changed is there's less work, right? Less construction spend. We're seeing an uprise in renovation, which is a good thing. In fact, a large number of projects that are happening globally are renovation projects. But this change in the economical state has really created a change in the way that firms are going about their business. They're trying to do more with less. It's creating different ways of doing things, firms striving for efficiency. The end result of this is also delivering new business models. So who would have thought that firms would be breaking down silos, collaborating in different ways? Who would have thought we would introduce things like integrated project delivery, really changing the dynamics of how design teams work together? The fourth thing is technology innovation. I can see a number of phones on the table. You're able to do so many different things with that phone today than you were 5 years ago. You can tweet, you can blog, you can take pictures, you can access the information that's important to you from anywhere at any time. That level of interaction with your personal information is what AEC firms are now requiring in their professional situations. Social media has forever changed the way that teams collaborate in their professional lives. What you'll see today also is how we're thinking strategically about the cloud, having access to technology innovation to inform decision-making and support the design process. There's also been a massive explosion of data. As we continue to move to a digital world, it means bigger models, bigger data files, and people are demanding access to this information when they want it. They're also really challenged with the question of how do they manage that data. So you'll hear us talk a little bit today about our data collaboration management solutions as well, and how we're trying to solve these challenges with technology. So beyond the macro issues that we're seeing in the AEC industry, there's 3 business challenges we're going to spend some time talking to you about. And you'll hear Kelly share some examples from his firm addressing some of these challenges. The first one is that we really believe that architects, MEP engineers, and structural engineers today are really faced with winning new work because of many of those things in the industry that I just spoke about. And today, winning new work really means winning new work with BIM. Firms who do not embrace building information modeling, quite frankly, are going to be left behind. The second thing is meeting client expectations. This is all to do with delivering sustainable, energy-efficient projects that meet with those evolving building codes. The third thing is increasing profitability. There's never been a more important time for firms to keep an eye on that bottom line. Do more with less, streamline their design processes, but also expand their service offerings, move into new areas to increase their profitability. So what I hope that you'll see today is how the depth and the breadth of our portfolio is solving these business challenges. It's supporting architects and engineers during design by enabling them to use intelligent models to create better buildings. It's enabling them to support visualization, present those ideas more clearly. It's enabling them to simulate, use project information early and often to inform decision making. And it's allowing them to document using coordinated and consistent models. It's also providing them access to this intelligent information that they can use to gain project insight from conception to construction. Now, I'm sure many of you in the room are very familiar with our traditional design portfolio. You've probably looked at products like AutoCAD and Revit for a number of years. But what I want to spend some time talking to you a little bit about is that solving business challenges with our portfolio goes beyond those traditional design tools that you might be thinking about. For example, here on the screen, in the spirit of talking about hospital design projects again, what you see in front of you is actually an operating room, a surgical room. What you see here in the center is the operating table. Let's think about an MEP engineer for a minute. An MEP engineer faces a number of workflow challenges, some of them being accurately designing the systems in a building, in this case, in a hospital. They're challenged with making sure those systems fit accurately within the building envelope, accurately within the structure in which they're working in. They're also challenged with making sure that there's tenant comfort or occupant comfort, making sure that the building or the room is accurately heated or cooled, just like the challenge with that room today, making sure that we feel comfortable as we sit here as capacity increases. They're also challenged with making sure that airflow is optimized. So what you see here, this was produced using Autodesk Simulation CFD. You see that stagnant air is actually flowing directly over the operating table. Why is that a problem? Because 2 out of 10 surgeries in the US result in an infection being contracted from airborne germs in an operating room. This results in over 290,000 infections happening in the US in the operating room. So imagine how using the Autodesk portfolio, again, let's think about the MEP engineer, They could use Autodesk Revit to design the MEP systems, optimize them, make sure airflow is optimized, also look at heating and cooling. They could also use Autodesk Simulation CFD to optimize the airflow. You see now how the air has been optimized, the airflow with the stagnant air is moving away from the operating table. This example actually came from our customer by the name of Hunt Air. In this situation, they actually were designing the system that you see at the ceiling here. They used Autodesk Inventor to put the modularized parts together, and they used Autodesk Simulation CFD to run those simulations, make informed decisions, move that stagnant air away, if you remember from the previous version. It's also about tools like Autodesk Inventor. Imagine a structural engineer who might be involved in a project that requires very specific connection and hooks. They could have used Autodesk Revit for the design, but they could also then use Autodesk Inventor to take a look at designing and fabricating the necessary connection and hooks to withstand some of the building components. Here on the screen, what you're seeing is Autodesk Inventor showing you how to model those components, making sure that you can then extend those into fabrication. We can also use Autodesk Inventor for stress analysis, making sure that the behavior of this connection or hook is going to be what we expect it to be. So with the depth and the breadth of our portfolio, we're seeing customers use tools in new ways. The Building Design Suite has provided people with access to a broader set of tools, enabling them to overcome these business challenges that they face. This example is from Burr Happold, a global MEP and structural engineering firm I'm sure many of you are familiar with. Burr Happold on this project actually used Autodesk Revit for the design. They used Autodesk Robot Structural Analysis Professional to conduct the necessary structural analysis, make sure they conform with the building codes. And they used Autodesk Inventor. One of the biggest benefits that they saw from the expanded portfolio in this project example was the ability to export their model from Revit after they've conducted the analysis into Inventor. They could literally then create the modularized components and deliver a shrink-wrap model to their architect back in Revit. The architect was then able to fit the modularized components of this building together like pieces of Lego. So beyond the existing portfolio today, we're also thinking about anticipating future customer needs. I mentioned BIM adoption is continuing to increase. As it does, we're going to continue to see MEP engineers and contractors embrace building information modeling in new ways. They're going to demand the intelligence of BIM all the way through into construction. So we made an acquisition of MEP software microapply packages in October of last year. We're in the process of integrating that portfolio into our MEP portfolio. And what it's going to enable us to do is extend from design into detailing, fabrication, and install for MEP building systems. We also last year launched the arrival of one of our new programs called the Consulting Systems Integrators Program. The first partner in this program was Gary Technologies. We're partnering with Gary to help firms answer that question, answer the question of how do I do BIM. We're working closely with them to work with customers who are challenged with this question to help them overcome that chasm, move from 2D or their AutoCAD-based workflows into building information modeling. So now let's talk a little bit about how we're extending BIM with the 2013 portfolio. I'm going to show you ways that we're expanding BIM with desktop products, and then we'll move on to talk a little bit about the cloud, and then you'll see Armando walk you through some examples using a hospital data set in just a minute here. So the primary offerings for building design industry today are the Building Design Suite 2013. This is further supported by an expanded tool set, meaning we've added new products, and I'm going to walk you through this in just a minute. It's also about the addition of automated workflows. Armando is going to walk you through a couple of examples of how now architects and engineers from within the design environment, so within Revit, can easily, quickly access through automated workflows products like Showcase and 3ds Max Design. It's also about the arrival of Autodesk 360. You probably heard Amar this morning speak about Autodesk 360. This is our cloud computing platform. And we'll talk to you a little bit about what is new in the cloud computing platform for architects and engineers. So let me pause here for a minute and let you take a look at this slide. This has been a popular slide today as people get to grips on what's new in the suites, and I'll talk a little bit about it. So in the Building Design Suite Premium Edition, one of the most exciting things is Autodesk Revit. The beta feedback on Autodesk Revit has been tremendous as architects and engineers realize they've got access to a broader set of tools. I'm going to change the slide for a second, but we can certainly come back to this. Now, Autodesk Revit is enabling architects and engineers to collaborate in new ways, experience and enhance BIM workflow. It's exclusively available in Building Design Suite Premium and Building Design Suite Ultimate. Let me describe again exactly exactly what Autodesk Revit is. So think about having one tool that gives you access to all the features of Autodesk Revit architecture, Autodesk Revit MEP, and Autodesk Revit structure in one application. Keep in mind again how I opened the presentation with showing you an example of where Revit was 10 years ago, predominantly focused on architectural design. Today, Autodesk Revit is supporting all the building disciplines, providing enhanced BIM workflows. The second thing that's new to Building Design Suite Premium Edition is Navisworks Simulate. And as you can see here from the screen, Navisworks Simulate is going to provide building design professionals with access to project review tools and visualization tools, enabling them to predict performance and scheduling prior to construction. And Kelly's going to give you an example, actually, of Navisworks Simulate in one of his examples in just a few minutes here. New to Building Design Suite Ultimate is Autodesk Infrastructure Modeler. Autodesk Infrastructure Modeler can be used during conceptual design for site planning and urban planning. So can you imagine here, taking a look at some of these strong visualization tools, how powerful a tool like Autodesk Infrastructure Modeler can be when you're sitting at the table with a project owner, being able to show them the impact that their building is going to have on the surrounding city. New to Building Design Suite Ultimate is Robot Structural Analysis Professional. This is going to make a great connection from design to analysis for our structural engineering customers. Provides access to a broad set of comprehensive structural analysis tools. New to the 2013 release is an enhanced integration between Autodesk Revit and Robot Structural Analysis, really enhancing that fluidity and bidirectional link between these two applications, helping to make a connection between physical and analytical models. We've also added new seismic analysis codes, providing access to a broader set of codes to meet those client expectations. So now let's talk a little bit about what we're doing in moving to the cloud. So as I mentioned earlier, Autodesk 360 is our cloud computing platform. It's providing infinite computing power to architects and engineers. It's going to enable them to rapidly design, simulate, visualize, and also collaborate in new ways. So of particular interest, and Armando will show you examples of these, to MEP engineers, structural engineers, and architects are these three services enabled by Autodesk 360. The first one is Autodesk 360 Energy Analysis. It's going to enable MEP engineers and architects to have insight into building energy lifecycle costs, powered by Green Building Studio. The second one is Autodesk 360 Rendering. Now quickly, we can access the cloud, create very fast, quick, very visual representations of our design using the cloud, removing that task from the desktop. For structural engineers, we can use Autodesk 360 Structural Analysis for Revit. This means we can upload our model to the cloud, we can conduct simultaneously static analysis, we can continue in our design environment while the cloud's doing its analysis work. Those results can then be reviewed within the Autodesk Revit environment. It's going to help inform decision making.
Excuse me,
yeah.
Can I ask how the structural analysis of Revit in 360 is different from the robot structural analysis?
Sure, absolutely. So Autodesk 360 Structural Analysis is really for early design. It's focused on static analysis. Robot Structural Analysis Professional is much more comprehensive and more detailed analysis. So that's the difference. But interesting to know, Lashmi, that 360 Structural Analysis is based on the engine that's within Robot Structural Analysis. So before I hand over to Armando, I just want to conclude a couple of key points that I focused on here. So for this year, it's really about expanding BIM. Expanding BIM with the Building Design Suite and the new expanded tool set. It's also about moving to the cloud. That's with Autodesk 360. And it's about the combination of these services and products together on the desktop and cloud that's providing greater flexibility and accessibility. I'm now going to turn it over to Armando, and he's going to walk you through some of these new tools that are available using a hospital design project that I mentioned. He's going to assume the role of an architect, an MEP engineer, and a structural engineer to show you how these tools are overcoming some of those business challenges that our customers face.
Thank you, Sarah.
No problem.
So, as Sarah stated earlier, we're going to look at how the 2013 Autodesk Building Design Suite really extends the BIM workflows on the desktop as well as on the cloud. And it helps to solve business challenges that our business building design professionals are facing today. We're going to start by looking at the extended BIM workflows for the Building Design Suite, in particular using Autodesk Revit, and how that solution is going to benefit the architect, MEP engineers, and structural engineers. Now, one of the first things you'll notice about Autodesk Revit is, as Sarah said, we combine the tools And now we have a broader set of tools and more comprehensive to allow for architecture design, structural engineering, as well as MEP engineering. All of that comprehensive package. Now, you ask, what's the benefit for that? Why would architects say need to use MEP engineering tools? Well, I'm glad you asked that, because I'm going to share that with you in a little bit. But in the meantime, we also have the ability, because we know sometimes during your workflow, you don't want to see those other tools. Well, we've made it optional so that you can now easily toggle on and off the tools you'd like. For example, as an architect, they may say, well, I want to look at the structural tools, but I don't need to see the MEP engineering tools. So let me turn those off. You'll see immediately that as I do that, the Systems tab has been removed. Just that quick, just that simple, just that easy. As well, if I look back, go back to these options, let's look over this a little bit. I can add those tools back in, but you'll also see another sub-segment around the analysis in the tools for structural analysis, mechanical engineering analysis, as well as the electrical and piping analysis tools. So they're available to you, really making it easy for the building design professional to choose how they'd like to set up and configure Autodesk Revit for their workflow needs. Now, let's go ahead and move on with this. Go ahead and get started. The first workflow we're going to look at is how Autodesk Revit can be supported to support architects using MEP engineering tools. Now, in this first example, what we're going to look at is we have an existing building renovation here, where we have existing ductwork that's in the project, and we now need to understand how we want to deal with that. How will it look aesthetically? Do we want to have exposed ductwork, or do we need to hide it behind something? So previously we had to close Revit Architecture, open Revit MEP, model out the ducts, close Revit MEP, reopen Revit Architecture, and then continue on working on our design. Well, that's an okay workflow, but we wanted to make it much smoother. Well, with Autodesk Revit 2013, we now have those broader set of tools that are available. So in this case, the architect can go in, they can quickly model out the ductwork and to see how it's going to affect the way that room is going to look with the exposed duct. Now they want to look at a different design option and say, okay, now we don't want to see them exposed. We want to hide those behind a bulkhead. They now don't have to close and reopen. They can simply use the architectural tools and add in a bulkhead to hide the ductwork to see how that's going to work. So the benefit there is that with these broader set of tools, it's going to help the architect, MEP engineers, structural engineers deal with multidisciplinary workflows. Our next example we're going to look at is how an MEP engineer may use the structural tools. So in this example, and believe me, I know I've been in it for 28 years, I understand this. Having these tools available, I just got a call from the structural engineer who says, hey, look, you put those 3 chillers on the 7th floor. Well, it's going to force me to change my structural framing plan on the 7th floor. I said, okay, so what you got to do? Well, I got to change my beam size. And unfortunately, they're going to increase. We're going to lose some space. I said, okay, thank you very much for letting me know. So when he does that, as soon as I get off the phone, I can access Autodesk Revit 2013 and now use my structural tools to come in and now lay out a beam that the structural engineer said he's going to place. I can come in, place this beam, and at this time, I want to make sure that I have the right size initially that he stated. So I can place that beam. One of the things you'll notice how quickly and easily the MEP engineer can access the structural tools. So what I'm going to do here is I'm just going to lay out this beam to see how it affects my design. I'm not changing the structural model. That's still going to come from the structural engineer, and it'll update. All the structural beams that you see currently here are all from the linked structural model. That doesn't change. All I'm bringing in is this single beam here just to see how it's going to affect my piping design here. So if I continue here, I'll see that based on my design right now, I know that I have enough clearance space between the bottom of the beam and the top of the pipe. So I know I'm good to go. But now, because I got that phone call from the structural engineer, giving me a heads up of the design change he's going to make, I don't have to wait for him. I can now come in and quickly lay out a single beam, and then I want to place it in the right location. So I'll lower it to 6 inches so it's beneath the floor. It's able to carry the loads of the chillers and that floor. The moment I do that, make that change to 18 by 15, I immediately see, wow, now I don't have enough clearance space between the bottom of the beam and the top of the pipe for them to be able to install the pipe. So now I have options. one of the first things I'm going to do is get on the phone call with that structural engineer and say, hey, yeah, I understand the change, and I've already realized that it's going to affect my design. Now I have two options. I can either ask the structural engineer to either decrease the size of the beam in order so my pipes will fit, or I can simply move my pipes down. And having been in this business, I've never once won the argument to get the structural engineer to change the size. So we know that. But at least I know instantaneously, 5 minutes after the call, I already know that I have a problem. I don't have to wait an hour or two for the file to come over to tell me that I have an issue with clearances. Make sense? Okay? And so now we're going to transition, and let's talk about, because Sarah mentioned we have actual new tools within Autodesk Revit 2013 that facilitate and support the needs of the architect, MEP, and structural engineer. Now, new for the architect, they have some new tools that are available to them as well. And one of the new tools is an interactive ray trace mode that's available to the architect. Now, this is going to help enhance their visualization. Now, once the camera stops adjusting, the progressive refinement is going to start to begin, and you're going to see it come to fruition. Now, another area is we no longer have to we can now bring in a custom background image rather than exporting the Revit image out to other software. We can bring that in, and now we can also use the tools for the sky and the image to start to be able to understand and better visualize exactly how the building's going to look aesthetically with the backdrop. Now, these visualization enhancements are also going to really help them to be able to better communicate their design intent to their clients. Now, what that benefit does is to help them to be able to win new work as well as meet that client's expectations. Now transitioning to Revit 2013 for structural engineers. One of the new features around the structural, the tools in Revit 13 for structural engineers is the ability to more accurately create and modify analytical models. As we all know, for structural engineering, it's about analysis. With the new grips and the new widgets, we can now use direct manipulation to adjust the analytical model so that it'll run correctly during the analysis. Another new tool is the ability for it to have the analytical model ignore openings that are there in order to run the correct analysis. So the results of the analysis is critical because you don't want to have openings in that analytical slab or the floor because that will hinder the results. Here we can tell it to just ignore it, and we get the correct results that we're looking for from a structural engineer. In addition to that, we have new tools around precast concrete workflows. With that, we have new enhancements around 3D reinforcements. As you can see, we have rebar here. But what is the benefit of that? Is that we can now actually run collision and interference detection on the rebar itself. Imagine that. What can that do for us? That actually extends our capability beyond just design into fabrication, detailing, and scheduling. It allows us to not only fabricate, but also assemble off-site the structure, precast concrete walls and bring that into the project. And also with these new enhancements, allows us to do more around the detailing side. We can take the new 3D reinforcements and create the details necessary for our construction documentation. Because we all know, we don't end there by sending a model. We still have to create construction documents. And with the new tools in Revit 2013, we can do just that. You'll see that not only can we create the details, but we can create the documentation necessary for it to be a part of the project. Now, finally, we're going to look at new features for the MEP engineers. Now, granted, I'm going through quick, and I've only shown you one new feature for each of the disciplines. There are many more new features and enhancements available. We just don't have the time to go over them. And as Paul mentioned, we can always talk off after hours and set up an interview to really go into detail about these new features. Now, for the MEP engineer, we got new pressure loss tools that are available to the MEP engineer. This is really, really important because it helps us to optimize the flow for our system. This will help us to meet clients' expectations and in some cases exceed it, as well as to make it more profitable because we know this system is optimized. Sarah stated earlier that it's important for our clients to be able to increase their profitability in these hard times. By optimizing the system, Sarah stated that 80% of the cost of a hospital is done after the design and construction. Here's where we optimize the system, saving them money years and years down the road. That's the benefit to make them more profitable. Now with the new tools, we have a system inspector tool, and notice that this is a single duct segment here. We're able to identify the pressure loss and the flow decrease for a single segment. And this is based off of taps instead of T's. If it was T's, you'd have a separate segment. It's easy to identify the flow loss by selecting on that. We could do that previously. But now with the taps, we can identify it even for a single duct segment. As the flow is being pushed out to the diffuser, we can identify that. Now we want to take that a step further because we can see that with the system inspector tool, but we need something more visual, something that's going to remain there that we can go back to and immediately identify where the pressure loss is going to be, where the flow is going to decrease. Well, here I can add a duct color fill schedule that now is available for not only flow, but for size and velocity. And just that quick, we're able to identify. Keep in mind, this is still one duct segment, but yet you can see each area where the flow and the pressure loss has decreased. Powerful tool for MEP engineers to optimize their design. Again, meeting those client expectations and helping to increase their profitability because the systems are more optimized for operations. Now we're going to move on to extending BIM workflow, BIM with automated suite workflows. We have new automated suite workflows from Autodesk Revit to Autodesk Showcase and Autodesk 3ds Max. Now Showcase is an easy to use yet very powerful tool that allows architects and engineers to be able to quickly show a client visualizations. Now, just as easy, sitting at a board table with your client, you can quickly create fly-through animations to show the client exactly how it's going to look. In addition, you have the capability now in 2013 to add storyboards. Here, the architect can go in and put different facades on the Showcase model where they may show brick or they may show another exterior facade. Just that quick. Doesn't affect the design model whatsoever, but yet you can do it on the fly with your client. The client says, well, I want to see it with brick. You can add the brick on there just that quick and allow the client to see how that's going to look. Very powerful. As well, we have another automated workflow for Autodesk 3ds Max design. Now, this is important because it allows high quality, high rendered visualization images that will help the architects win new work. Now, keep in mind, think about the previous workflow prior to these automated workflows. We had to take the Revit model, export out to FBX, open up 3ds Max, bring it in, tweak it a little bit just to see it. With the automated workflows, we can go straight from Autodesk Revit, straight into 3ds Max or Showcase. Now, Sarah talked about being in the cloud. Let's look at how we're going to extend the BIM workflows in the cloud with Autodesk 360. In this case, we're going to look at Autodesk 360 rendering for the architect and engineers. Now, with Autodesk 360, rendering, for all those who've been able to render, know that this is heavy, heavy computations. It's time intensive on the desktop, and it takes up a lot of time. More often than not, you'll sit at the render, walk away. You're not going to get a coffee. You're probably going to go to sleep because about 24 hours later, depending on the size of the model, you'll have that rendered. Now we're taking that process off the desktop, put it in the cloud. Now the architects and engineers can continue to move on with their design in Revit. And then with the Autodesk single sign-in, it's going to send us an email notification when the rendering is done, and we can come right back, open it up, and see the images. Not only do you have still images, but you have panorama views as well during the rendering. Again, time saving for the architects and engineers. Next, we're going to look at the Autodesk 360 for structural analysis. Now, Sarah did show you some earlier about analysis for structural engineers. That too takes a lot of computing power in order to do. So we've done with Autodesk 360 structural analysis for structural engineers allows us to take the analysis, move that again off the desktop, saving time so the structural engineer can continue designing, send that to the cloud, and then when the analysis are done, the results are brought back in a document via the cloud. Lets you know you can see the results, understand it, and then be able to design more efficient systems. It really helps that engineer to make better informed decisions. In addition to that document, you can then take the results from the cloud and bring it right back into the Revit environment and populate the Revit model so you can see the results directly within that Revit model. So we've already got benefits from the cloud documentation to bringing it into Revit, but it takes us a step further. We can bring that down to the iPad as well for mobile communication. Imagine the power of that, having the analysis there, bringing it onto your iPad and being able to look at it no matter where you're at. You're getting ready to go on the plane, you run your analysis in the cloud, you're at the airport, you simply log in, bring it down. Now you can start to review it on the plane. Couldn't do that before when you're dealing with the desktop. And now we're going to take our last look at how we're going to extend BIM into collaboration and data management. Now, we all know that at the heart of the design process, it's really about collaboration. As an MEP engineer, I've got to work with the architect, the contractor, the structural engineers as well. So we've got to collaborate and coordinate. I need to be able to talk to Kelly and he to eye and be able to communicate so that we can affect change before it is so costly. So we're going to look at extending BIM workflows using Autodesk Buzzsaw. One of the big new features with Autodesk Buzzsaw is the ability to then turn around and bring in native Revit files. That's an RVT file on Buzzsaw that we can view in the Buzzsaw viewer. We can manipulate it, we can move in, we can zoom in, we can even see the information, that IM/BIM, that data actually in Buzzsaw if we use a select on components. But we've taken it a step further than that because in addition to having it there, there's also a thing called Buzzsaw Mobile in which I now have my Revit model on my iPad. Able to do the same thing, expose it. Let me come over here, bring this over. So I can see the view, and now I can make changes. I can look at the model, verify, walk around the site, see what's going on, and be able to identify it straight from the Revit model. I don't have to convert it. Now, when we're talking about construction documentation, don't forget about what we talked about last year, AutoCAD WS. We can still use the DWG construction documentation to bring down from the cloud into our iPad, and now, in addition, I can take that, mark this up, send this back to the office, allow them to make a design change. They can then post it back to either Buzzsaw for Revit viewing or create it for AutoCAD WS and then share that. Now I've updated it, and this is a matter of time depending on how long it took to make the change, but I'm quickly and easily able to support the extended workflows. And so you can see here, I know it's been fast-paced and I've showed you a lot in this short period of time, but the benefits to the MEP engineer and the structural engineer and the architects truly help support them to be able to meet client expectations, win new work, and increase their profitability. And with that, I'll turn it over to Kelly. Thank you.
Thanks, Armando. So I'm going to give a quick introduction just about the firm that I work for. The firm that I work for is an integrated services provider, so we do development, architecture, construction, and technology. So it gives us kind of a different outlook on some of these tools and how we've been using them over the last 5 years, particularly, kind of our focus on BIM. That kind of integrated mindset, we've been looking at ways to get costs out of Revit for, almost 6 years now, before there was a QTO or any other products to do it. So it's definitely a driving force for us. And then I want to echo some of what Sarah said earlier in terms of some of these influences in the market. Efficiency is definitely driving our business. It changes how we design buildings, performance requirements. It changes how we construct buildings. We're also seeing the kind of commoditization of our profession and our fees and everything else, as well as our tendency to push risk downstream. And those are driving new business models. So IPD, integrated enterprises like Beck, prefabrication, and then some of these fabrication-centric design firms are all kind of evidence of that pressure on the market. And anytime you have these new processes, you're always looking for new tools or new combinations of tools that help you actually get your job done, because it's now your job's a little different than it was before. So it's always a challenge for us. Now, one of the big ones that we run into is how to differentiate ourselves in the market. Get out there, there's a lot of competition for projects. How do you really stand out? Because BIM's not cutting it anymore. Everybody does BIM, at least in the markets that we are in. So BIM's kind of a prerequisite to play. You've got to actually be able to talk to the clients about how you can use BIM as a tool to solve problems that matter to them. And that's how you can actually stand out and differentiate yourself. And I'll bring up a couple examples here. The Kimball Art Museum in Fort Worth, Texas, is building a new expansion to their Louis Kahn, their existing building. And this is a Renzo Piano design building. And it's like every Renzo Piano design building. It's a true masterpiece. It's incredible. architectural concrete, this incredibly detailed German glazing system. It's all there, but that provides a very unique challenge to us on this project as a contractor, because we've actually now got to coordinate everything before we even install a single wall, because the finish is the structure. We don't have time to kind of overlap the two. And, you know, like the Renzo Piano building, everything in the MEP is concealed. You're never really supposed to see it. So both floors are served through one ceiling plenum. You've got these very tight chases where all the stuff in the ceilings above the galleries have to run up, then go through glulam beams and in between this glazing system up at the top. And you're never supposed to see that. And it's so tight that, you know, a single nut, bolt, or hanger in the wrong place can actually cause a serious issue for us. So it's very critical we get these right. So we turned to the building design suite to really kind of solve this problem for us. We use Revit to model the architecture and the structural components, a very detailed structural concrete model. We use Inventor to do this glazed German system down to the nut and bolt. We're doing laser scanning on this project on a pretty regular basis to confirm that we're installing per the model. And all these different things, all these data sets are brought into Navisworks, compared for collision detection, for coordination walkthroughs, and to take them out into the field. That little tablet at the end of the table, that's what I walk around in the field with, making sure that we're getting stuff installed correctly. It's a very critical part of our process on this project. We're also responsible for doing all the documentation for the architectural concrete. And this is what's used to actually lay out formwork that then, you know, is what the concrete gets poured into. So it's critical that these things be right. And on a project like this, we have changes all the time. The day before we pour, we'll have a change. And something we would have struggled with in the past was, how do we actually make sure the field has the most up-to-date information so that this turns out right? What we're able to do is leverage Autodesk 360 and really take the DWIFs that we're pushing out of our model that have the 2D drawings and the 3D model. We're able to send those out to the field, and actually, you know, minutes after we get a change, the field is working again with the most current drawing. And this is really important to us, because if one of these goes wrong, it's $100,000 out of our pocket. So, you know, we want to get it right. Kind of an understatement. But, you know, it's also really important to, you know, try and coordinate early on in design. And this actually, this would be kind of a good workflow for what Armando was talking about earlier. This is one of those things where we're constantly trying to work with our engineers to make sure that we're in live or as close to live models as we can off Revit server. But you always run into scenarios where you're trying to work with your engineer and make suggestions. We want things to go here or here. It's nice to be able to populate those in our model and then actually send them the model, and they can copy things from our model into their model and then actually figure out how to size them and make them work. It's a much better form of communication when we can model the structural components in our model, and then they can use those to help get to where they need to be in terms of their engineering. But again, it's really crucial to have everybody playing in the same, you know, same field. You can do some pretty incredible things. This Dallas Arboretum project is also very unique. This has a number of these kind of meandering, curving, organic forms working through the site. And it's a real challenge for us for constructing something like this, because every piece is unique and there's a lot of cost overruns that you typically see with projects like this. What we were able to do is use the Building Design Suite to come up with a workflow that allowed us to get around that. So we created the design model in Revit, and you can see these little red dots. We were able to take those, export just those points into Inventor, tie them to iCopy, and tie that then to our fabrication model. And now we can actually change the design model in Revit, and then within a day have completely updated shop drawings for all the steel. And that can also be pushed out to CNC for fabrication. So it allows us to shorten what would have been a 3 or 4 week process for getting all these shop drawings and the fabrication done to, you know, a day, and then it's ready to fabricate. So that really helps us bring a project like this in on budget and on time, which is obviously important. So, you know, differentiation isn't the only thing that's a challenge. Profitability, particularly with commoditization, we're always running into situations where everyone's cutting their fee. How do you make money in that kind of environment? We're all in this as a business. And the answer is you find new things to do to add value, and you try and figure out ways to get paid for that. but there's a kind of corresponding, you're taking on risk by doing something new. And the trick is to use tools to actually manage that risk and make it worthwhile. The Hinman project, this is in Atlanta, Georgia. It's for Georgia Tech, a new architecture school building for them. In this project, we got a very exacting millwork design from Office Da in New York. They were the design architect, we were the architect of record and the builder, and we were challenged with how do we take something this precise and bring it into a 100-year-old building where nothing's plumb. Our original bids for millwork subs came back 200% over budget. It looked like we were going to have to cut the scope out of the project. So we took it over. We used laser scanning to very accurately capture the existing conditions, brought that into 3ds Max, turned it into a mesh, brought that into Inventor. We were able to update all of the different assemblies and components in Inventor to actually fit the building. And then we were able to take that to a 3-axis router and basically fabricate all these millwork panels and then go and install them. And that saved us tens of thousands of dollars in materials, and it allowed us to get this scope in under budget and get paid some additional money for the work that we did. Changes are another big one, of course. That really hurts your profitability if you have a lot of changes, right, David? So, how do you manage that? On this project, we had over 50 changes to the curtain wall envelope because property lines in South Korea are negotiable. So we were constantly trying to keep up with it. And, that would have probably cost us 40 to 50 man hours per change with a traditional process. But because we built the mass of this building with a parametric form in the massing tools, and we mapped all of our curtain systems to this, we were able to incorporate a vast majority of those changes with less than a day's worth of work. And we estimate that it saved us about 1,500 man hours over the course of this project. And that's the difference between actually making your projected profit or losing money on a project. So very important. And then sometimes we design these great forms and we're like, okay, now how do we actually make sure this gets out into the field? And that same process where we create points and take them to Inventor, we can leverage that to actually take points and put them into data collectors and robotic total stations to make sure that when our field engineers are out on site laying out points, they're laying them out directly from the model instead of manually calculating them. And it saves us a lot of time and a lot of potential for error. And then the last challenge I really want to talk about is modeling and predicting results, really. How can we take these tools, because this is what BIM is really about, taking all this data and making a prediction in time to actually do something positive about it. On this Harim project, this is in South Korea as well, we had a kind of edict that this needed to support passive ventilation. Energy is very expensive in South Korea, and this is a really important thing for our client. So we actually were able to use the wind tunnel in Vasari to kind of figure out, all right, well, what are the general wind flow patterns, bring the wind rows in for the area, look at it, and then we were able to design a form that actually created pressure differentials on different sides of the building so that we could activate passive ventilation. And this was kind of curving slots, obviously a design element, but we also created this because it creates a high pressure zone on a part of the building that was almost always in low pressure. So it allows us to pull air from the backside of the building where it's turbulent and pull it through very consistently. So helps us out a lot. Sometimes we just use BIM as a visualization tool, though. Cost analysis is a pretty common thing for a contractor to do. You get a change, you figure out what is this going to do, and then you spit out 150 pages of numbers that nobody understands. That's a pretty difficult sell. You can take that same information, bring that into Revit, assign it to custom parameters, set up filters, and then you have this fantastic visualization that explains very clearly to a client why you have a change, what that change is, and what it's coming from. And then the last thing is schedule. Schedule's always important to clients. And when you have a client that's losing half of their campus, they're always very concerned that their services that they're providing to the community are going to suffer. And so how do you prove to that client that they can actually lose that half of their campus so that they get their new buildings that are important to their vision, but actually prove that, yes, you can maintain the services you're already providing. And Navisworks Simulate is a really good tool for us to kind of graphically display that with the schedule and get that client on board with our plan. And with that, I'll turn it over.